Hi everyone, in this video we'll discuss one of the most controversial examples or cases in applications of transformations of functions. So recall that whenever we transform functions we have to follow a specific order which we call sort, which means that compressions and expansions will be applied first and then reflections and then lastly the translations. Now, the question that I get asked very often is like, what happens if we change the order? So, would we still get the same answer? And it's also one of the more common mistakes that I noticed, repeating generations after generation. So, we're going to clarify this once and forever. So, as an example here, we're going to take the square root function and we are transforming this function, and the transformations applied are based on the equation y equals negative f of x minus 2 plus 3. So as you can see in here, we have created a new function by number 1 multiplying by a negative 1 in here. That means that the value of a equals negative 1. And then we have horizontally translated it. So that would be the value of d equals positive 2, 2 to the right. And lastly, we are vertically translating it 3 units up. So the value of c here is equal to 3. Now, if we want to create the equation of this function based on the parent given, then this would be y equals negative. Now you see the square root of x is the parent. So instead of the letter f, we are going to bring in the parent, which is the square root function. So that will replace the letter f, the entire letter f in here, by the way. And we're going to write x in here. So that is the parent function. So no more f, just the square root of x. And we'll apply in here the horizontal translation of 2 to the right, and then the vertical translation of 3 units up. Okay, so now the correct order of transformation would be to apply the reflection first. So since a equals negative 1, that will cause a reflection over the x-axis because the y values are changing. Always try to explain things to yourself in more than one way, because that's how we connect things. And we have the value of d equal to positive 2, so that's a horizontal translation 2 to the right. And this is enough for you to write when you explain these things on a test. And c equals 3, which causes a vertical translation of 3 units up. So I'm going to do things in the correct order as suggested by CERT. So I will reflect the graph first, and then I will translate it. So first, let's do the reflection. So reflection over the x-axis will take this parent function. So this is a graph of the parent function. I drew this in advance, so we don't have to waste our time there. And when we draw graphs of functions, we want to take a look, or we want to transform mainly the key points. And in this case, the key points will be these 1, 2, 3, 4, 5 points here. And we're going to take all of them to the other side of the x-axis. So we're going to take this one here, and this to the other side. So negative 4. So as you can see, this is where the points are going, right? Now we'll connect them. Okay, let's connect this as well, and this one in here, and the rest I'm just going to extend it. So this is going to be negative f of x, or you can also write negative root of x. Now next we will apply the translations. So for translations we normally like to apply them in one step. They're not too difficult. So 2 to the right and 3 up. So each and every one of these important points or key points, we're moving 2 to the right and then 3 up. So let's do this and see what we get. So 2 to the right, 3 up, we'll take this first point in here, 2 to the right, 3 up. So that's where the graph will start. Now we're going to take this 2 to the right and then 3 up. So we're going here. And now we're going to go again, 2 to the right, 3 up. Again, we're going to go 2 to the right, 3 up. Where are we now? Okay, so 1, 2, 1, 2, 3, yeah. And 2 to the right again, and then 3 up. So we're going to land right below 18. All right, and we're going to connect all these points. Voila, this will be our transformed graph. I wish I was better at drawing. Okay, so here we go. We have negative root of x minus 2 plus 3 here. Now careful, you want to extend the entire root to 2 to show that the minus 2 is actually indeed subtracted from x. And there go both graphs. And this should be our final graph right here. Now, what would happen if we change the order? What would happen if we felt like doing translations first and then reflect the function? So in mathematics, normally when two different methods can be used to solve a problem or to answer a question, they should produce the same result. So if the result is the same, then we're good. But let's take a look first. So if we want to apply the translations first, that means that we are going to draw the graph y equals the square root of x minus 2 plus 3 first. So we're going to take every key point from the parent function here, move them 2 to the right, 3 up. So 2 to the right, 3 up. Now we got, so this is the first one. And now 2 to the right, 3 up. And then 2 to the right, 3 up. 2 to the right, 3 up. And here we go. And then 2 to the right, and then 3 up will take us here. 2 to the right, 3 up. This will be the graph of y equals root of x minus 2 and then plus 3. Now we will apply the reflection. So the reflection will be over the x-axis, which means that this point here is going to go to the other side of the x-axis. So that will take the first point down here. Now next we have this point in here will go all the way down here. Now this point here will go all the way down here. And then same thing, we have this point down here, and then we'll have this point all the way down here. So this will be the graph of the reflected function, right? Now let's compare the final graph. So the final graph, when we followed all the rules, was this one here. What color do we want to make it? Something that stands out. All right. So I'm just going to do the pink here. And this graph, the final graph here, is down here. Now, you see that these are not the same graphs, right? Their locations are different. So, which means that one or the other has to be or is incorrect. Now, we don't know which one it is, but we're going to trust technology on this. So what we're going to do is try to draw the graph on decimals. As a matter of fact, I pre-prepared this for us. And if you are at home or if you are in front of a computer, what we can do is just click on this link. It will take you to the graph of the function. Come on. All right, so as you can see, the graph that we see here, I'm going to try to take a snapshot of it so that we can see it better. Hopefully it's gonna work. Okay, it did. Okay, good. All right, so let's bring it there on the screen. All right. And I am going to copy this. Okie doke. Great. So if I brought that same graph in here to compare it, all right. So let's make this graph travel a little bit. So when you compare it with this graph in here, you see that it is the exact same one that we got, right? You see this one here. It's the same as this one here. And alternatively, then we're going to say that when you compare it with this function in here, it seems that they don't match. And we're going to trust Desmos on that, right? Because Desmos is so smart. And we're going to say that the first graph is correct, which means that reflections have to be done first and then translation. And this is incorrect. So we're going to cross this out to make it a little bit more memorable. So please don't do translations before reflections. So we did not obtain the same graph. And we checked with Desmos, and now we want to explain this because we want to know why did this happen. And here is the reason why. This is how we explain it. So if we have the function y equals f of x, the parent function, and we want to get to the graph of the function y equals f, negative f of x minus 2 and then plus 3, okay? So in other words, we had y equals square root of x, and we wanted to change this to y equals negative the square root of x minus 2 plus 3. So this is our final product. This is what we want to get. Now, what happened in the first case scenario? So when we apply the reflections first, so we change y equals root of x first to y equals negative root of x. And after this step, we take y equals negative root of x to make it into negative. We apply the translations x minus positive 2 and then plus 3. And that will give us, the graph of or the equation of the function, the desired function. Now, this is when we follow the reflection first. Okay, so we reflect first and then we translate second. Now, if we decide to translate first, so what happens is that y equals square root of x. I'm going to have to create a little bit more room for us here. Okay. So if we have y equals square root of x, and we apply the translations first, then we are creating y equals root of x minus 2 and then plus 3. Now, this will be the translated function. Now, next we are going to reflect this. So this is going to be a reflection of the y values, or reflection over x-axis, same thing. So I'm going to write off y values because that is important in this case. It can help us understand it better. So if you are reflecting the y values, then you're reflecting these y values, or should we say these y values? So what that means is that the y values now are becoming the opposite of what they were. So negative of what they were. So I'm going to grab this y value the way it is. I will copy and paste it to make sure that that's the exact same y value that I have reflected. Now, when you reflect this y value, you got to keep it in brackets because you're reflecting the entire thing, right? And if you were to simplify this, it means that negative root of x minus 2, right? So you're applying the reflection on this term and on this term in here. So negative and negative 3 as well. So the positive had changed to a negative. So is this the function that we wanted to graph? So is this the equation we wanted to graph? You see, the equations are different, right? So algebraically speaking, this is how you would explain why the change in the order of transformations didn't work, okay? And again, we go back to that BADMAS. So we have to follow BADMAS for a reason. We have to follow the order of transformations again for a reason. So I hope these explanations were memorable enough for you to remind yourselves that how important it is to follow the order of transformations and to understand why reflections have to be before the translation and why the other way around doesn't work. So I hope you found the instructions useful again, and thank you for learning with me. Bye for now.